Our concept today is the concept of rate of change. As you look at this graphic here and you see it says the change in y's versus the change of x's. In the past, you might have seen this a little bit differently. You might have seen this as the rise over the run, the concept of slope. We're changing vocabulary just a little bit now. We're calling it a rate of change because you're looking at a comparison of two numbers. You're looking at, in this case, the output, the y's. We've seen this as the output compared to the x's, which we've seen as the input. The rise versus the run. The y's compared to the x's. The dependent compared to the independent. This is where our vocabulary comes in once again, and we need to know what we're talking about. The best example that we can use to look at rate of change is the concept of speed. Distance versus time. Miles versus hours. In this case, we're looking at the table where we're comparing the y's and the x's. We want to see what happens as we drive every 2 hours, how far do we go? In this table, as small as this table is, we can compare right here 76 to 152. In 2 hours time, we're going 76 miles. If you look at the next part of the table from 152 to 28, you're still going 76 miles and it's still taking you 2 hours. Would you look at the rate of change, you make the comparison. Every 2 hours we increase by 76 miles. As you look at the rate of change in the algebra form of it, distance versus time, 76 to 2 or 38 to 1. What does this mean? We're going 38 miles every hour. Rate of change means the car is traveling 38 miles per hour. This is a great graph to show the fact that when we're looking at segments, in this case where it's truly segments we're looking at, this is the passports issued between two different time frames up here. We can look at rate of change. In this case, we can look from 2002 to 2004. What's happening? Well, we're going from 7 to 8.9 in a 2-year period. Then you can do the same thing again, and we can look at a different 2-year period. We go from 8.9 to 2.1. We're looking at segments this time. We're still looking at rate of change. We're still looking at the concept of how much does it rise versus how much does it run. How do the y's increase compared to the x's? And we can look at different rates on segments. 2002 to 2004, 8.9 to 7, change in time, 04 to 02, about 9.5. What does this mean? We always want to put a real world meaning to this. Everyone, let's see, 1.9 million in a 2-period time, or 950,000 per year. We look at the comparison to the other segment here from 04 to 06, 2.1 to 8.9. We're looking at 3.2 million every 2 years, or 1.6 million per year. In a segment form, we can look at individual pieces from here to here, and then those two pieces there. In segments, our rate of change can be different. But then as we change and we talk about what's called a constant rate of change, this is where the concept of lines versus segments come on. When we look at a constant rate of change, we want to look, does the graph stay the same the whole time? Is it constantly doing the same thing over and over again? In this case, from 6 to 12, we go up by 6. From 12 to 18, we go up by 6. From 18 to 24, we go up by 6. That's constant. From 1 to 2 is an increase of 1. 2 to 3, increase of 1. 3 to 4, increase of 1. That's constant. This is linear. We go back one slide and we look at, is this linear? Yes, the segments are. From right here to here, that is a segment, not a line. So we have to look at the differences there. Is this a line? Is this constant? We go from 5 to 1. Okay. We go from, which is a decrease of 4. From 1 to 4, we automatically see that's a decrease of 5. From 4 to 10, that's a decrease of 6. That's not constant. We have to make that and see that this is not going to be linear. This is not constant. You can look at that example and make the comparisons there. 2 to 4, 4 to 6, 6 to 8, 6 to 8, that's going by 2s. 5, 10, 10, 15, 15, 20, that is also. 2 to 16 is 4, 16 to 20 is 4, 20 to 24 is 4, 3 to 6 is 3, 6 to 12, right here is where it becomes not linear. When we talk something that's constant, we're talking about the concept of slope. Slope is a constant rate of change. We're talking about lines, not segments, lines. When we change this out, and if we were to look at a parabolic curve here, does this have a constant rate of change? No. Every little segment from here to here is different than from here to here, which is different than here to here, which is different from here to here. We can look at those segments again and see that there's definitely a rate of change, the y's compared to the x's, but it's not constant. A line is very unique in the fact that anywhere we look on the line, in our graph here, if we look from this ordered pair to this ordered pair, or if I were to put another ordered pair up here, x3, y3, that rate of change, that increase compared to that piece here, it's going to be the same no matter what. And that's what makes a line unique.